3.4 notes, function operations, page 3. We get to get a little creative here and look at different ways to evaluate compositions of functions. So example 5, we have got 3 separate functions that we are working with, and so we just have to make sure that we are going in the correct order. So g of x inside most, we are going to start with that. So f of h of g of x gives us f of h of our g of x is x minus 6. So that's what gets plugged into function h, which is the square root of x. So we have f of now square root of x minus 6. That x minus 6 became the argument for h of x, which is the square root of x. And then finally, f of x, so that square root of x minus 6 gets raised to the 4th power, and we add 6. So f of h of g of x ends up being square root of x minus 6, all raised to the 4th power, plus 6. We can simplify that. Because that's the square root of x minus 6 squared plus 6, which gives us x minus 6 quantity squared plus 6. That hasn't gone anywhere. X squared minus 12x plus 36 plus 6, and we get x squared minus 12x plus 42. B, we've got f of g of h of 49. If you'd like, this would be a great time to pause the recording, give this one a shot, and then turn it back on and double check. So h of 49 happens first. F of g of h is the square root of 49. Gives us f of g of 7. 7 gets plugged into function g. So we've got f of 7 minus 6, which gives us f of 1. 1 to the 4th plus 6, 1 plus 6, and we end up with 7. So again, using the functions here to find the values of the composition. Example 6 gets a little different. We've got 3 functions in terms of their graphs. So we have the pictorial representation. F of x is a parabola, g of x is that square root function, h of x is the absolute value. We are going to use these graphs to read our function values. So we're going to start here, f of 1. F of 1 is 1. And so we can substitute that in. So now we're looking for g of 1. Let's see if we can. So we go to function g at 1. I got g of 1 is 1. So we end up with 1. B, g of f of 2. F of 2 is 4. So now we're looking for g of 4. And we go to function g. Here's my 4, g of 4 is 2. C, f of g of 4, well, we just established that g of 4 was 2. And we know that f of 2 is 4. which kind of makes sense. F of and g are inverse functions, the square root and the square. It seems reasonable that they would undo each other. D, f of g of 1. We know from looking at our middle graph that g of 1 is 1. We know from looking at our first graph that f of 1 is 1. So again, it looks like f and g undo each other. E's got f of 2. F of 2 we already know is 4. Now we need f of 4, but that's not on the graph, but we know that this is a parabola. This is the function f of x equals x squared. So we can figure out what f of 4 is. That's 16. F, we have h of f of 2. F of 2 we know is 4. We want h of 4. So here, the far right function h, when x is 4, y is 4. It's the absolute value function. F of g of h of 4. Well, we just found h of 4 was 4. Let's see if we can. And so now we have g of 4. Where else did we have g of 4? G of 4 we know is 2. So now we're looking at f of 2, which we've cranked out before. We know that's 4. F of g of f of negative 2. So back to the far left, f of negative 2 is 4. So we can plug that much in, f of g of 4. And this looks familiar. Looks like exactly what we had on C. G of 4 is 2. So we're looking at f of 2. F of 2 is 4. Lots of 4s. Example 7. Pretty consistent, except here we're using a table instead of the graph. So that open circle means composition. This is actually looking for f of g of 1. And so let's see what we can do to color coordinate here. G of 1, here's my 1. G of 1 is 0. So now we're looking for f of 0. I'll pick a different color. Here's my function f. There's my 0. F of 0 is 5. F of g of 2. G of, wrong one. So we got g of 2. Here's my 2. Just can't quite get it. G of 2 then is negative 3. So we got f of negative 3. And we want, here's my negative 3. F of negative 3 is 11. G of f of 2. F of 2. Here is 2. F of 2 is 1. So G of 1, that works. G of 1 is 0. This should be D. We have g of 1. And g of 1 we just did. We know that that is 0. So now we're looking for g of 0. There's the 0. G of 0 is 1. G of f of 3. G of f of 3. Here's my 3. F of 3 is -1. So now we're looking for g of -1. Here's our -1. G of -1 is 0. F of 3, we've got f of 3. We've already done f of 3 once. Right, that's the brown over here. F of 3 is -1. So now we want f of -1. Which is 7.